So a lot of the course so far has focused on key management. In effect, your keys need to be unique, or maybe you want to have certain key patterns, and in what scenario can you insert a key that already exists and either expect an exception to be thrown back or to have the document be created or updated as necessary. That's been a lot of our focus. So in traditional RDBMS scenarios, we're used to the idea of auto-incrementing columns that just guarantee every key is unique. That's also possible in Couchbase. Let's take a look. So one of the most powerful aspects of Couchbase is that it scales elastically across a cluster. This is huge for performance purposes. There are no single points of failure, and you can add additional nodes to your cluster at any time, or take them away for that matter. But that raises an issue if you're trying to come up with a unique number. If the specific machines behind the cluster, the specific nodes where your value may be written, are potentially ever changing, how do you know you're getting a unique value for that particular node? Well, if you stop and think about it, it's quite easy. In Couchbase, really, you could invent this yourself. We simply use a document. We can create counter documents that are maintained, in effect, just like any other document, and as you'll see, you can go find it in your bucket. This document is then equally available from any node in your cluster, just like any other document. And it's also always available at in-memory cache speed, regardless of your cluster activity. So if over time your cluster is scaling up and scaling down and the write logs are being migrated around and compacted and replaced in the background, it doesn't matter. As far as your client is concerned, you always have a unique value. So how do you go about getting a unique value? Well, we're back to the bucket, as you might expect. It supports an increment operation that takes name, step, and initial value as parameters. The name is the name of the document that's going to be created. It's the name that you use to reference which unique value you want to work with. Step is how much the value is incremented in any given execution of the increment operation. And initial is the initial value for the document. It's where it all starts. As you'd expect, step and initial default to 1 if you don't otherwise specify. So I could, as we see here, pass in a document name, in effect, the key for the counter document of customer : counter, just to keep it in line with our other customer documents, which is where, in this lab example at least, we are focusing our use of the incrementing counter. And then we take the result of calling increment and append it to the document key and return it back as part of this particular method that we're demonstrating here. So we take the ID for a given document and append a key increment to it before we insert the document. So the value is increased by the step value on each use. Because this is stored as a document, these values durably persist across all your cluster activity. In the end, you end up with documents in a bucket, as you see here, that have auto-incrementing values appended to the end of each key, guaranteeing that each one is unique. Now, whether this is a better solution than doing an upsert or insert or replace, I mean, that depends on your needs and your application, but it's another tool for your tool belt. So in the lab, you'll implement a cluster-wide counter to ensure unique keys, get the hands-on practice through your fingertips. Then when you come back, we're going to take a look at the power of nickel. How do you put what you already know about structured query language to work, but this time with JSON documents? Select Insert, Update, Delete. You can do it all and a lot more. Come on back.